Hello, welcome friend. Welcome to our channel Quality Guru. Friend, today our topic is granulation area troubleshooting in OSD. The RMG and its principle. The rapid mixture granulator principle involves using a bottom entry agitator and a side mounted chopper to achieve dry blending, wet mixing, dough preparation, and granulation through a combination of rising, boiling, and tumbling motion. The process begins with dry blending, followed by slow addition of a liquid binder to create a wet mass. Finally, the impeller and the chopper run at high speed to break down the wet mass and form uniform granules. Key component of RMG: mixture chamber bowl, a vessel often dome or cone shaped where material are processed. Impeller, a bottom entry agitator that creates the rising, burling, and the tumbling motion of the powder. Chopper, a side mounted cutter that operates at high speed to break down agglomerates and cut the wet mass into granules. Discharge port, an outlet for removing the finished granules. Filter assembly, a vent filter that prevents material loss while allowing cleaning air to exit the chamber. How RMG work? The process: dry mixing. Dry mixing ingredients are added to the bowl and the impeller rotates at a controlled speed to ensure a homogeneous mixture. Binder addition. A binder solution is added slowly and eventually to the mixture while impeller speed is reduced. Duff formation. The impeller continues to rotate, creating a uniform wet mass. Granulation. The impeller and the chopper run at high speed to break up the wet mass and form granules of the desired size. Discharge. Once the granules are formed, they are discharged from the mixing valve. Why it works? Shear and compaction. The impeller and the chopper provide both compaction and shear forces, which are essential for mixing, densification, and agglomeration. Material movement. The combined action of impeller and the chopper create a uniform motion that ensure all material are evenly distributed and processed uniformly. Granule size control. The speed of the impeller and the chopper can be adjusted during the process to control the size and the density of the final granules. Purpose of blending in pharmaceutical industry. Blending is a critical unit operation in pharmaceutical manufacturing as it is a prerequisite for homogeneous distribution of drug component. Clearly, the content of active pharmaceutical ingredient, that is API, in the final solid dosage form is particularly important. Troubleshooting pharmaceutical granulation involve addressing issue with granules property like size, moisture, and hardness by adjusting process parameters such as liquid addition rate, agitator speed, drying time, and the binder concentration. Common problem includes fines, oversized particles, segregation, sieve blockage, and inconsistent drying, with solution often involving modify equipment setting, ingredient ratio, or processing condition to achieve the desired granule quality. Common granulation problem and solution. Fines. Too many fine particles indicate insufficient granulation or low moisture content. Action plan and the solution: increase the liquid amount, increase agitator speed, increase granulation time, or use a more appropriate binder. Lumps, oversized particle. This can be caused by excess moisture or excessive granulation. Action plan: decrease the liquid amount and chopper speed during granulation or use a coarser mass for sieving. Segregation. Different size particles separate during processing. Action plan: adjust agitator speed and mixing time or add fine ingredient after wetting to prevent separation. Sieve wet mill blockage caused by overweighting of or improperly set up milk. Action plan: adjust the mill setup, use a wider mesh size, or reduce the liquid amount. Inconsistent granule property. Issue like non-uniform moisture, density, and hardness can occur. Action plan: ensure proper drying and lubrication, verify the correct amount of winder, and optimize equipment setting and processing parameter. Poor flow ability. Granules that are too hard can lose compressibility, leading to poor flow during filling operation. Action plan: reduce compression force during granulation to achieve a balance between hardness and compressibility. Key area for adjustment: ingredient properties. Adjust the amount and type of winder, lubricants, and other excipient to control granule characteristic. Moisture control. Maintain optimal moisture level in the granulating liquid and during the drying process to ensure effective capillary action without overweighting. Equipment setting. Calibrate agitator speed, chopper speed, spray rate, drying temperature, and drying time to match the batch requirement. Processing parameter. Control the duration of mixing, the rate of liquid addition, and the overall granulation time to prevent over to under granulation. Blend uniformity analysis BUA. Blend uniformity analysis is a routine and highly regulated aspect of pharmaceutical production. In most instances, it involves quantitative determination of individual component of a blend in order to ascertain the mixer ratio. Blend uniformity is a critical factor in the formulation of oral solid dosage form, such as tablet and capsule. Here are several reasons why it is important. Content uniformity. Blend uniformity ensure that the active pharmaceutical ingredient is eventually distributed throughout the dosage form. Failure to meet the expected uniformity in the final product may be caused either by suboptimal mixing and insufficient initial blend homogeneity, or may result from further particle segregation during storage, transfer, or the compression process itself. The acceptance criteria of blend uniformity analysis is as follows: RSD, relative standard deviation of all individual results, is not more than 5%. All individual results are within 10% absolute of the mean of the result. 90% to 110% of added amount active drug substances, that is API. Thanks a lot, and keep watching our channel. Please like, comment, and subscribe more and more. Thank you.